8.7, which states that if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Now observe the statement of theorem 8.6. 8.6 states that in a parallelogram, diagonals bisect each other. So we were given a parallelogram and we had to prove that diagonals bisect each other. You can see it was given that ABCD is a parallelogram, and you had to prove that AC and BD bisect each other. The diagonals bisect. The converse statement is theorem 8.7, which states that if the diagonals of a quadrilateral bisect each other, so the conclusion has become the given, then we need to prove that it is a parallelogram. So the given here has become the conclusion here. So we are given that ABCD is a quadrilateral, not a parallelogram, it's a quadrilateral, and the diagonals are bisecting each other. That means AO is equal to OC and BO is equal to OD. We need to prove that ABCD is a parallelogram. For this, we are going to use theorem 6.3 of chapter number 6. So let's recall. Theorem 6.3 states that if a transversal intersects two lines such that a pair of alternate interior angles is equal, then we can say that the two lines are parallel. That means if the alternate interior angles are equal or one pair is equal, then we can say that the two lines are parallel to each other. We are going to use this result to prove the theorem 8.7. Now let's read it. Theorem 8.7. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. So we are given ABCD as a quadrilateral, and AC and BD bisects each other. So we join the two diagonals and we know that AC and BD bisects at O. That means AO is equal to OC and DO is equal to OB. This is given. AO is equal to OC and OB is equal to OD is given. We need to prove that ABCD is a parallelogram. Now, let's see the proof. Let us take the two triangles, triangle AOD and triangle COB. You will see that it's already given to us that AO is equal to OC. AO is equal to OC. This is given. Also, we have angle AOD equal to angle COB because they form vertically opposite angles. Now look at this. Angle AOD is equal to angle COB. They are vertically opposite angles. And also it's given that DO is equal to OB. So you have DO equal to OB. So by SAS rule, we can say that triangle AOD is congruent to triangle COB. Now, since these two triangles are congruent, we can say that angle OAD is equal to angle OCB by CPCT. Let's see which angles are they. So angle OAD, this angle is equal to angle OCB, this angle, by CPCT. But you can see they are alternate interior angles if you take AC as the transversal. So we will say that therefore AD is parallel to BC. AD is parallel to BC because these angles are formed by AD and BC taking AC as the transversal. Now let's take other two triangles. Triangle AOB, which is the orange triangle, and triangle COD, the green triangle. Triangle AOB and triangle COD. Here also it's given that AO is equal to OC. AO is equal to OC. Angle AOB again will be equal to angle COD because they form vertically opposite angles. So we will have angle AOB equal to angle COD. because they form vertically opposite angles. Also, BO is equal to OD is given. So BO is equal to OD. This is given. Again, by SAS rule, we can say that these two triangles are congruent. Now that these two triangles are congruent, we can also say that angle OAB is equal to angle OCD. OAB is equal to angle OCD by CPCT. So let's look at this angle OAB. This angle is equal to angle OCD, this angle. And you can see they both are also alternate interior angles. So if you take the line AB and CD and AC as the transversal, these two angles form alternate interior angles, and because they are equal, we can say that AB is parallel to CD. Now, as we have proved that AB is parallel to CD and BC is parallel to AD, we can say that ABCD is a parallelogram.